problem 1. The average of the first 6 weights was 10 pounds. The average of the next 4 weights was 20 pounds. What was the overall average of the weights? Whenever to ask this question, you're looking for a total sum over total number of numbers. Alright, so if we take a look at the first statement, the average of the first 6 weights was 10. So the average was 10, the number of weights was 6. So when we look at what average means, the average is equal to the sum over number of numbers. So looking at what they're giving us, they're telling us the average was 10, they're telling us that, and the number of weights was 6. So if we consider that what they give us is an average of 10, the sum, we'll call that S sub 1 for the first sum, over 6 weights. If we just cross multiply, we get the first sum is going to be 60. And then if we take a look at the second statement, the average of the next 4 weights was 20 pounds. Okay, so the average is 20, the number of weights is 4. So again, the same scenario here. The average, which is 20 pounds, is equal to the second sum divided by the number of weights, 4. Again, cross multiply, you get S sub 2 is equal to 80 pounds. So if the average weight of the average of the first 6 weights was 10 pounds, they added up to 60 pounds. 4 weights, 20 pounds, they added up to 80 pounds. So altogether we have 140 pounds, which is the total sum. And the number of numbers, there were 6 weights and 4 weights, that's a total of 10 weights. So the overall average here ends up being 14 pounds. Anytime you do overall average, it's going to be in between the two averages given. So the averages are 10 and 20, 14 is between that. It's going to be closer to the one with the more numbers going into it. 10 has 6 numbers going to it, 20 has 4, so it's going to be closer to 10, 14 is closer to 10 than 20, so that verifies that it seems like a reasonable answer. Number 2, 18% of 1,300 is what number? So it's a percent proportion problem. Anytime you see a percent proportion problem, some percent of some number is some number. Start off with the percent proportion. Always put the percent first. Let's say 18%, so 18 goes over 100. The percent's done. We've used it. Over here we do is over of. The word of is next to 1,300. The word is next to both 1,300 and what number? So of only has one choice, so that's got to be the of number, so 1,300 goes here. Once we use 1,300, the only thing left is what number? That's what we don't know. Again, is on top, of on bottom. At this point we cross multiply. 100 times x is equal to 18 times 1,300. Which is 23,400. And once we get that cross product taken care of, we simply divide both sides by 100 to get rid of the number in front of x. So 234 is the right answer. It doesn't have to come out to an integer, but just know that you set the proportion up correctly. Is on top of on the bottom again. If one has more than one choice, do the one with only one choice first. Start with the percent. One of these only has one choice, do that. And whatever's left over is the other one. Same deal. What percent of 50 is 80? So start off your percent proportion. Always begin with the percent. This says what percent, which means we don't know. That's our unknown. Once again, we got the word of that's next to 50. We got the word is, which is next to both 850. So of only has one choice. We'll do that first. Of goes in the bottom. 800 then would have to go on top. Because again, we've already used 50. There's only 800 left. At this point, again, we cross multiply. So this product, 50x, is equal to this product, 80,000. You multiply numbers that end in 0, multiply the numbers that aren't 0, 8 times 1 is 8, and then just include as many zeros as are there. Divide both sides by 50. So 8,000 divided by 5 would be 1,600. 1,600%. Number 4, solve. This is an equation. It has a mixed number, a fraction, and an integer. First thing I would do is I would change the mixed number into an improper fraction. So 3 1/3, 3 times 3 is 9, plus 1 is 10, so we're going to get 10x over 3. And then minus 1/5 equals negative 6. Just rewrite the rest of the problem, just modifying what you need to modify. The next thing I like to do is get rid of fractions, so I'm going to multiply by the least common denominator of the fractions, which is 15. And that's multiplying every piece of this by 15. So when I do 15 times 10x over 3, divide first, multiply by result. So 15 divided by 3 is 5, times 10x is 50x. 15 divided by 5 is 3, times negative 1 is negative 3. And if you're multiplying by a non-fraction, just multiply 15 times negative 6 is negative 90. That problem has the exact same answer as the original problem. There's no fraction to deal with. It's just easier to do. So what's left to do now is to solve this. This has x, nothing else does. I'm going to get the things without x on the same side. Anytime you move something across equal sign, simply change the sign. Negative 3 becomes positive 3. 50x is left on the left-hand side. Negative 90 plus 3 I'm going to subtract. Because the signs are different, I'm going to make it negative because 90 is bigger. Divide both sides by 50. That gets me x equals negative 87/50. And I personally like improper fractions, so I'm going to leave it right there. Number 5, a decimal equation has a little distributive property going on. You can decide to work with decimals or not. Again, I prefer not to. So what I'm going to do, first off, I'm going to distribute here. And when I do this distributive property, I'm also going to make everything have the same number of decimal places. So 1 decimal place, 2, 1, and then none and 1. Don't worry about this, don't worry about that so much. So 2 decimal places is the most anything has. So I'm going to make everything have 2 decimal places. So as I rewrite this, I'll use different colors. So 0.3k is going to be 0.30k. Minus 3.06 is going to stay minus 3.06. Minus 0.7k is going to be minus 0.70k. And then when I do the distributive property, this product's going to be minus 3.00k. Be careful that whole numbers, integers also create decimals. Put decimal 00 to represent 2 decimal places for negative 3. And then this times this, that one there, is going to be plus 1.2. I'm going to put a 0 on that also, 1.20. So everything has the same number of decimal places, 2 decimal places, 2, 2, 2, and 2. Once everything has 2 decimal places, you can rewrite the problem in exactly the same form, just without the decimals. So the original problem is this. The new problem becomes 30k minus 306 minus 70k equals negative 300k plus 120. And just like that, you have an integer equation instead of a decimal equation. Again, for my beliefs, integers are easy to work with. So I'm going to move the 306 over to the right-hand side. That creates all the integers on the right-hand side. I'm going to move the 300k, which is negative, to the left-hand side. So everything k is on the left-hand side. If I combine like terms on the left-hand side, everything here has k. 300 minus 70 is 230, plus 30 is 260. And 120 and 306 makes 426. In this case, I subtract because the signs are different. Positive 230 and positive 30 make positive 260. Here the signs are the same. I simply add the 2 numbers. 426 is what you get. And the last step, as with most of these equations, we're going to divide by what's in front of the variable. Variable's k, divide by 260. That is the correct answer. It does look reducible. I can see for a fact that 2 divides both numbers for sure. To go beyond that, seeing if anything else goes into these numbers, if you look at the prime factorization of 130, 13 times 10, which is 2 times 5. Okay, this isn't even, so 2 doesn't divide it. This doesn't divide by 5 because it doesn't end in 0 or 5. If I try 213 divided by 13, it doesn't come out to a whole number, so no number that goes into 130 goes into 213, so that's the reduced correct answer. I'm not going to count an unreduced answer, but just try and create a habit where you're reducing whenever possible. Number 6. Okay, the trick to this problem is simplification and being careful in your simplification. The first thing I deal with in this problem would be this distributive property here within the brackets. This -3 I'm going to hang on to until I get this bracket, the entire bracket, completely simplified. So looking at this expression, what's inside this bracket needs to be simplified completely before I deal with that -3. The other thing I deal with immediately would be this power and this power, okay, before I distribute on that other one. So this distributive property is happening here, but I want to evaluate that first. So if I go -3 bracket, again I'm not dealing with that -3 until I get the brackets completely simplified. The distributive property happening here is going to be positive 3k plus 12. And I've said this a bunch already, I'm going to reiterate. Always go the leftmost term first, the rightmost term second when you're distributing, no matter what side this is on. Always go from here to the leftmost first, this one second. Always do that product first, that one second, in that order. I'm going to keep -2 minus 6k in parentheses. I haven't distributed yet, so it stays in parentheses. The minus and the 3 are both being squared because the square is outside the parentheses, so -3 times -3 is equal to +9. 2 is being squared, the minus sign isn't, so it's being subtracted by 4. Be careful that you don't create some multiplication out of this. That's a subtraction symbol. Stay subtraction. 2 to the second is 4. This thing has to be evaluated before the -4 is dealt with. So that would be my first step. Second step, I'm going to combine like terms in here. I'm going to do a distributive property here. Everything else is going to stay as is. So -3 stays outside the bracket. 3k is still 3k. 12 minus 4, opposite signs make 8. 12 is bigger, so it's positive. Okay, now the bracket's completely simplified. Now the next step I can distribute. Here I'm multiplying 9 through this parentheses. Come here first. 9 times -2 is -18. 9 times -6k is -54k. Alright? And then the next step, again, in simplifying, I'm going to deal with the distributive property here, and I'm going to combine like terms here. And then the problem's simplified as much as possible, and I can start solving. So, distributive property, -3 times +3k makes -9k. -3 times +8 makes -24. -54k is not being messed with in this step. -18 and -4, I'm going to add those because the signs are the same. And it's going to be negative because 18 is bigger. And just like that, I went from the original problem as it was into a simple problem. Letter number equals letter number. At this point, I want to get letters on one side, numbers on the other, so I'm going to move the 54k to the left. Negative becomes positive. I move the -24 to the right. Negative becomes positive. Again, I make my decision, should I add or subtract based on signs? These signs are opposite, so I subtract. 54 is bigger, so it's positive. Opposite sign, so I subtract. 24 is bigger, so it's positive. And if 45k is equal to 2, we divide both sides by 45. So k is equal to 2/45. Number 7, solve for p. These words simply mean p equals everything else. So if it's p, it stays on one side. If it isn't, it goes to the other. So this has p, this doesn't, this doesn't. This a has to move to that side. So 3p equals 7 minus a. Just move something across the equal sign, you change its sign. Once you get to something times what you care about, again, what I care about is p. Once you get something times what you care about equals the other thing, simply divide by the something. Okay, I don't want the 3p, I just want p, so divide by 3, divide by 3, the 3's cancel. P P is left on the left-hand side equals everything else. That's all that problem is. Okay, some of you are making that a lot more difficult than it needs to be. You get P isolated, divide by whatever's in front of P, circle your answer. Number 8, graph. Y equals x plus 1. The technique for graph we're using right now is simply an XY chart. You get to pick any x you want, and you solve for y. I'm going to pick 0, 1, 2. And x equals 0, 1, 2 just means that we're changing this value to 0, 1, and 2, and we're finding that value based on this equation. So if x is 0, 0 plus 1 is 1, so y equals 1. X is 1, 1 plus 1 is 2, so y equals 2. X is 2, 2 plus 1 is 3, so y equals 3. You pick x, the equation determines y, every ordered pair gets graphed. So 0, 1 gets graphed here, 1, 2 gets graphed here, 2, 3 gets graphed here, and just like that we get 3 dots lined up, nice straight line. We connect those dots with a line with arrows on the ends, like so, and we get our completed graph. So the dots you get, I recommend 3. If they line up in a nice, pretty straight line, you probably have the correct line. So that's how you graph a line for now. Number 9. When you're adding algebraic fractions, the denominators help create the least common denominator. To create the least common denominator, simply write down every factor that occurs. X occurs and y occurs. And the highest power of every one of those factors. X to the first, y to the first, so first. That gets me x, y as the least common denominator. Once I know the least common denominator, then I'm going to make a big fraction bar with my least common denominator on it. And I need to recreate these fractions with the correct numerator for each changed denominator. So, the one I have circled in red, 2 is the numerator already. XY stays XY, nothing changes, nothing happens. So this one's fine, no changes necessary. Second fraction starts off with minus 5. This is x, it became xy, y is new, so we got to multiply negative 5 times y. Next fraction starts off with negative 3 in the numerator. The denominator was y, now it's xy. X is new, so x is necessary on top. So that's what you do. Just compare the denominator from what it was to what it is. It didn't change, nothing happens. It changed by y, put a y on top. It changed by x, put an x on top. Once you get each numerator fixed, the answer's right there. We simply have to write it in the prettiest form possible. Xy on the bottom, 2 can't be prettier than 2. Minus 5y without the parentheses, minus 3x without the parentheses. Subtraction is impossible because the letters are different. There's no cancellation possible, so that's as far as I can go for that problem. Number 10, we're supposed to add these polynomials. Now, this is polynomial 1, and polynomial 2 is being subtracted and multiplied by 2. So we want to distribute that one. This number with the sign included, 2 and negative sign, are being multiplied by each of those terms in there. So, first thing I would do is I would write down this exactly as it is. There's nothing in front of my parentheses, there's nothing being multiplied by it, it's being subtracted by that. So, this parentheses is there for effect only. Every power of x cubed squared x to the first and constant, cubed squared x to the first and constant. They have the same types of letters, so I don't have to do any kind of modifications here. So, 5x cubed minus 3x squared plus 4x minus 5. Just rewrite it as is, in the order that it is. And then I'm going to multiply negative 2 through that parentheses, lining up like terms. So negative 2 times x cubed, putting that underneath 5x cubed. Negative 2 times positive 4x squared makes negative 8x squared, put that underneath negative 3x squared. Negative 2 times negative x makes plus 2x, put that underneath positive 4x. Negative 2 times positive 1 makes negative 2, put that underneath the constant. Cubed, squared, first power constant, everything's lined up like terms. And then you just have to make a decision, should I add or subtract for each pair of like terms? Different signs subtract. 5 is bigger, so it's positive. Same sign add. 8's bigger, so it's negative. Same sign add. 4 is bigger, so it's positive. Same sign add. 5 is bigger, so it's negative. This does not have to have a sign if it's positive. Every other thing has to have a plus or minus in front of it. So this was negative minus, this was positive plus, this was minus negative. And it does say descending order of the variable. Some of you are getting me the right answer but not doing that. These start off in descending order, which is great, but descending order, in case you didn't understand before, let me just highlight that. Third power, second power, first power, no power. Okay, power of x is counting down. Third, second, first, nothing. So that's descending order of the variable. It has nothing to do with the numbers, it has to do with the powers of x. So this is officially x to the first power, obviously, and no x at all is really x to the 0 power, because x to 0 is 1. So when you have a constant, that's the 0 power of x. That's why it's still descending with that. So I think some of you were not missing that idea. So anyway, that's what descending order means. That's the answer. If you give me the right answer in not descending order, I'm going to get you half credit, at least for having the right answer. But if it doesn't have descending order, you'll lose half credit. Number 11, multiply. And keep in mind, if we're multiplying a binomial to a power, what that truly means is that 2x minus 3, what's being squared, is being multiplied by itself. And if 2x minus 3 multiplies by 2x minus 3, if I use FOIL, okay, remember FOIL, F stands for first. First term times first term gets me a product of 4x squared. O stands for outer. Okay, these two terms are the outer terms of the four terms. They multiply positive 2x times negative 3 makes negative 6x. I stands for inner. Again, you got four terms. These two are the inner terms. So negative 3 times 2x is negative 6x. And then L stands for last. Those are the last terms. So binomial 1, binomial 2, those are the terms in the last spot. These are the terms in the first spot. Negative 3 times negative 3 makes positive 9. Make sure when you're multiplying that signs do come into play. Same sign positive, different signs negative, different signs negative. Once we get all four of these products, then we simply combine like terms. These are the like terms, nothing else is. So 4x squared is fine the way it is. Negative 6x and negative 6x make negative 12x. Addition because the signs are the same. Negative because 6 is the same. They're both negative. Plus 9. And notice, x squared, x the first constant, descending order of the variable. That happened automatically. It doesn't necessarily have to happen. But again, when it does say do this, x squared, x the first constant, that's descending order. Number 12, multiply. Write the answer in descending order of the variable. When we're multiplying a single or binomial times a trinomial, the best way to do this is do this first object times this entire second thing. So x times each thing. So x times 3x squared is 3x cubed. X times 4x is plus 4x squared. X times 5 is plus 5x. Notice positive times positive, positive times positive, positive times positive. We get a bunch of positive answers. Notice that this is descending and so is this. So cubed, squared, first power, this is descending, which is fine. Again, if things aren't descending at the end, just rearrange it. Then I'm going to multiply 2 times all of this stuff. And again, multiply 2 times each one of those things. 2 times 3x squared is positive 6x squared. And notice I'm lining that up with the 4x squared. 2 times 4x is positive 8x. I'm lining up that with 5x. 2 times 5 is plus 10. That would be the next term down in descending order. And it has no like terms with it, so it gets its new column. If you line up like terms like that, the last step is simply to add those like terms together. 3x cubed doesn't have any, nothing happens to it. Positive 4 and positive 6 make positive 10x squared. Positive 5 and positive 8 make positive 13x, and then plus 10. And again, plus, plus, plus. Those pluses are necessary. If you leave them out, you're going to be wrong. So make sure that you not only get the correct answers, but make sure there's a plus or minus sign in front of each answer based on what sign it should be. Again, the first term positive can be understood. Every other positive must be written. Number 13, simplify. Okay, if we follow the process that I've given you, the first thing I want to deal with is negative powers. So I've got a negative power here, and here, and here, and here, and also 0 powers. Everything else is a positive power, so everything else stays where it's at. So everything that's not highlighted is going to stay where it's at. I'm going to rewrite that first. So m to the fourth and p to the fifth and x cubed and x squared and x cubed on the bottom and p cubed on the bottom all stay right where they're at. Nothing happens to them. Everything I've highlighted in blue, I'm going to modify. 0 powers equal 1. Multiplied by 1 doesn't do anything, so I can just strike out a 0 power that's being multiplied. Everything else that's highlighted as a negative power. They belong in the other part of the fraction. These two belong on the top, these two belong on the bottom. So if I move a p squared up and an x squared up, that takes care of this one and this one. If I move an x to the fourth down and a p to the fourth down, that takes care of this one and this one. So every object in that original problem has been dealt with. The positive powers stay where they were, the negative powers moved, the 0 power went away. Now we're left with this problem. Second step that we're going to deal with in this problem is we want to get the top as simplified as possible, the bottom as simplified as possible. And the way we do this is we consider things of the same type. So on top, I've got m's, I have p's, and I have x's. M's affect M's, P's affect P's, X's affect X's. So, there's only one M on top, nothing happens to it. There's two P's on top. I add 5 and 2, I get 7. There's 3 X's on top. 3 plus 2 plus 2 is 7. On the bottom, again, dealing with things of the same type. I've got X's and I have P's. I personally like order to be similar, so I'm going to put the P over the P, the X over the X. So looking at P, I've got 2 P's, 3 plus 4 makes 7. I've got 2 X's, 3 plus 4 makes 7. Okay, the final step, once you get the top as simple as possible, the bottom as simple, there's one of each, there's one of each. Once you get to that point, then you look to see if you have the same thing on top and bottom. If you do, you have to deal with it. Okay, the rule states that we're supposed to divide by subtracting powers, but in the case of these where they're exactly the same, they cancel. Those cancel, those cancel. So we're left with m to the fourth. Put it over 1 if you feel like it, but that's the answer, m to the fourth. On the test, I can't guarantee that happens. Let's just say the other scenario. Let's suppose we got to m to the fourth, x squared, p to the third, over x to the fourth, p squared, something like that. Okay, so looking at the x's here and the p's here, if we get to this expression, m to the fourth, of course, is perfectly fine where it's at. X belongs on the bottom because 4 is bigger than 2. 4 minus 2 is 2. P belongs on top because 3 is bigger than 2. 3 minus 2 is 1. So that's how you'd handle it if we had different powers as opposed to the same powers here. The first power is not necessary to be written. If you wrote m to the fourth, p over x squared, that'd be fine also for that specific situation. But again, what's above this line is what the problem was. This is the correct answer. This is just a what if. If this type of thing should happen here, that's how you handle that situation. Number 14, expand by using the distributive property. The first priority on a problem like this is to deal with negative powers, fixing these objects so they're as simple as possible. So x squared over y to the negative second is not as pretty as it can be. This is, and so is this. So I need to fix that. So x squared, y squared, which I'm going to put over 1. I've got fractions of the problem just to establish position. So x squared and y squared are both on top. There's only a 1 on the bottom. That's not going to affect the denominators. And then this inside part, we've got y squared over x squared being subtracted by 6x squared over y squared. Alright, so if I distribute, this red thing's going to multiply by this blue thing. When you distribute, when you multiply, just do top times top, bottom times bottom. Don't overthink it. Don't try and make it more complicated than it is. Don't try to cancel things as you're multiplying. Just multiply it. So x squared times y squared on top makes x squared y to the fourth. 1 times x squared on the bottom makes x squared on the bottom. Then we multiply this, the red times the green. Positive times negative makes a negative. X squared y squared times 6x squared. 6 isn't being multiplied by anything. X squared times x squared makes x to the fourth, and y squared times nothing makes y squared. On the bottom, 1 times y squared is y squared. So that's priority 1. Get the multiplication done. Once you've multiplied, then you can worry about canceling if possible. In this case, I've got x squared over x squared. Those are exactly the same, so they cancel completely. Here I got y squared over y squared. They're exactly the same, they cancel completely. What I'm left with is y to the fourth minus 6x to the fourth. Number 15. A base of a right solid 12 meters high is shown. Find the volume of the right solid. Okay, so the directions are to find the volume. The volume formula that I've given you, area of base times height. Area of base means that we're going to look at this base and find its area. It's a triangle with a semicircle, so we have to find the area of the triangle, find the area of the semicircle, add those together, that gets me B. H is height of solid. If we see a three-dimensional picture, which I don't, the height would be on that. If there's no three-dimensional picture, we should expect the height of solid to be in the words, 12 meters high. So sometimes people think 16 is the height because that's the height of the base, but the solid is 12 meters high, that's what H is. So basically what I have to do to get this problem done, B equals something, H equals 12. I have to figure out what B equals. Looking at the base, I've got a triangle. Again, the height of the triangle, since the radius is 8, 8 up and 8 down make a total of 16. The triangle dimensions are 16 and 16, so the area of the base is going to equal the area of the triangle. And I'm going to add to that the area of the semicircle. Semicircle is going to be pi r squared, but it's only half a circle, so divided by 2. Okay. It'll be the same figure on the test, different numbers will be used though. The height will probably be different too. But just keep in mind it'll be a triangle, semicircle, 1/2 times base times height. Be careful, the height is established by the radius, 8 up and 8 down make a total of 16. And again, pi r squared over 2, half a circle, whole circle formula divided by 2. If I work this out, half of 16 is 8, 8 times 16 is 128. 8 squared is 64 times pi over 2. 64 times 3.14 divided by 2 comes out to 100.48. So altogether, the area of the base that I need over there is simply these two numbers added together, so 228.48. It says dimensions are meters, so this is square meters. 228.48 square meters. And again, this is 12 meters high. See if we multiply B and H, meters squared times meters makes meters cubed the correct volume unit. So volume is simply going to be 228.48 times 12. My calculator says 2,741.76 cubic meters. I would expect you to use a calculator for some of these calculations. Applying the formulas correctly, using the calculator to verify that we get the correct numerical values that we're supposed to get.